How are you going today? Oh, it's a really nice sunny day here in Melbourne. We've been enjoying the sun and doing some real life gardening, which has been really nice. A little bit inspirational, maybe. So today we're going to go over part 2 of the little gardening game. So if you didn't see the first stream, that's totally fine. You're welcome to just kind of watch along and see what we did. And then we also have, let me just show you the stream channel so you know where to go. So this is obviously the stream that's happening right now. Whoa, meta. But actually, if you want to download assets, you can find them here. And there's like kind of the upcoming streams and past sessions all there. So you can jump onto YouTube and watch the previous one if you want to. But we're actually going to go into the downloads, and I'm going to download the files from the last lesson or last session, and we'll just start from there. So we're kind of all at the same point if you want to follow along. Something I'll be doing this time, which I didn't really do last time, is having a little bit more intermissions and breaks just so that everyone can catch up if they want to. And also I'll try and keep this stream a little bit shorter just to not wear everybody out a little bit. And I'll try to do this more regularly. So every 2 weeks there'll be a stream of some description for about an hour or an hour and a half. As usual, please let me know if you have questions, comments, if you have design ideas, just pop that in the chat. I'm more than happy to have any thoughts that you have added to the game we're making and stuff like this. I want this to be interactive, and it's also not really a kind of tutorial channel, so it's not really about here's this particular way of making this particular game. It's much more about, hey, I'm a programmer and a developer. How about you have a look into how I work and how I think? So that's kind of the purpose of this channel. Okay, cool. So we're going to start by downloading these assets. So in here, there's actually just the straight off PSD, which we used in the first stream. And then this is the wrap up from the first stream. So all of the files I put into a zip and put up online. So you can download these. So I'm going to get them. And from the last session, I also went through and commented all the code. So if you weren't sure about something, when you open up those files, you should be able to see a little bit more kind of information about what I was doing in the code. Okay, so I'm just going to, I already have these gardening ones here, but I'm going to make another, like a duplicate of it just to kind of let you all follow along without any worry. So I'm just going to call it Gardening Game Part 2. Or Little Gardening Game Part 2. Oh no. Part 2, yeah, awesome. And I'm just going to extract that in. Is that done already? That was quick. Cool, so are my files. So a really cheeky way you can open assets in Unity is you can just go straight into like the Unity scene file and double click it, and usually it will try to, this might ask me to, I guess opened in Unity on my other screen. You can double click it and it will open it. But what I'll show you instead is the normal way I do it, which is so I use Unity Hub. You don't have to use Unity Hub. That just lets you have multiple installations of Unity if you do lots of projects. So like, for example, I have quite a few projects going on, so I have this so that different versions of different projects can use different versions of Unity if they need to. Reasons you might do that is like, say you're building a game and it's like quite old, but you need to upgrade it or something, like you need to make some new changes to it, but you built it like 3 years ago. You don't want to have to upgrade to latest Unity because there's all these weird assets that come along with it. Sorry, let me close this one that opened from the scene, from the Explorer view, from double clicking on the scene. So yeah, you can double click on this, but actually a much safer way to do it, because that can do some funny stuff if the folders are not quite right. A safer way to do it is actually to just always go through this open dialog here. And as you can see, like I've already got, look at, I actually added it in there. It's pretty funny. This is the last session. This is the one that just opened then from Explorer. And I'm just going to add a new one just to be totally on the safe side. Here's on the desktop. Here's my little gardening game part 2, which I spelt wrong. So I'll just correct that here. Gardening game. Beautiful. And select that folder. And it's like, oh yeah, cool. What do you want to run? I'm like, yep, that looks good. That's the version I want to run. And Unity is booting up. And there it is. This is where we left it off last time. Can I get a quick look from anyone who's watching, anyone who didn't watch the last stream or did watch the last stream, just so I get an idea of whether I should kind of touched on some of the topics we did last time, or if I should just all be building on it instead. Just let me know in the chat. I'm just going to quickly do this. Great. Okay. And cool. So here's where we were last time. So let's just hit play and we'll see what the game is up to. So it's a little bit offset in this version now, which is a good problem we can solve. And I think if we click on this, we highlight this object, and then we can click on some ground. It digs a nice little hole, and then we can plant some seeds. It makes a little mound. So that's basically where we're at right now. Awesome, Similar. Thank you for sending a message in there. Cool. Okay, so this is kind of where we're at. So where we take this is kind of, I mean, it's up to me, but it's also up to you. So we can do lots of different things. We can look back at our assets. So let's see in our art. So here's the sprite sheet we used, what different assets we had. So we can see we've got some water. So we could try adding some water in. And obviously we've got the plant itself that needs to grow. So maybe we'll make our watering can tool, and then we'll make that make the plant grow a little bit when we water it. So do that. But if you have other ideas, feel free to post them in. Chat channel them in? What's the right terminology for that? Not sure. Okay, so let's do a quick recap of our code as well and our scene. So our main camera has nothing special on it. It's just a regular main camera. In the dirt, we've got all of our dirt patches. Let's just zoom out a bit. Whoops. All of our dirt patches in the ground there. So these are just the aesthetic ones. If we move them around, it's just kind of the texture in the background. We've got the dirt top. So this is a little bit smarter. It knows kind of what's going on, and they're prefabs. So if we recall, prefabs are a way of kind of bottling up sets of work so we can drop them back down again. So to give an example of that, here's the dirt, and I can just pop it in the world, and it has all of the same logic that these dirt prefab, or these dirt prefab instantiations have. Instantiations. Cool, so I don't want that one. And we can see on them we've got a collider, so we can check for our click effect. So we can do a collision raycast from the screen. We'll do a click into the world, and then that will hit this collider, and that's how we can tell if we're clicking it. And there's a little bit of logic on the dirt, so I'll double click on dirt. That will open up Visual Studio for me. If you're using an older version of Unity on Mac, you might get Mono Develop instead, but they're it's the same kind of thing. Then we have over here, there we go, and Visual Studio just opened on my other window. Oh, what's it doing? There we go, it says Visual Studio. Minimize it for now. Then we have our tools, so the shovel, the watering can, and the seed. Cool. And they all have this cool little tool select script on them. This one has it here. Let's make it go up there. So you can just drag, if you want to change the order of these things, you can drag them around. And normally the order doesn't really make a difference. The one exception to this is very particular. There might be more exceptions that I don't know about, but one exception I do know about is if you're doing post effects on a screen. So that's like if you're doing grading effects or outline effects and stuff, the order that you have it on in here will actually affect the order that it changes the camera pixels. But that's like just a little bit of trivia knowledge, I guess. Cool. So we can, just like we did with the dirt, we can double click on tool select, and that will open up that code for us. I'll zoom this in so you can all see it a bit better. And you can see this is all really commented from the last session. So lots of notes on kind of what everything does. And if you have more questions, if there's things missing, please feel free to ask questions or send me a message on Twitter or something like this. Cool. So I have a question from Stu Left. I'm just going to quickly read that. Interested in seeing the structured time sequences. Wait 1 second. Play animation. Wait a second. Yep. Excellent. Yep, I think that's a really cool idea. So I'll just read it out for the video recording, which might not have the text in it. So I'd be interested to see how you structure timed sequences. If you'd like to set a sequence running, play animation, wait 1 second, play another animation, wait half a second, change the image, and then it plays out on its own, perhaps with the ability to interrupt. I don't know if you see a place to use that in this game. I think there's actually a really good place to use that, and that could be for, so say we plant our seeds. and then we water them, and we want to wait. So there's going to be an animation that plays out, and then we wait a little bit, and then we can water it again, and there's another animation that plays out. We water it a third time, and then we get to that last, the last art asset with the, let me bring that up, with this here, and maybe like after a little bit of time, all of these little flower, like berries kind of pop up on it. Oh, sorry, flowers and then berries. So it's definitely something we could explore in this, all going well with time. And yeah, so I won't run through exactly what the code does. And like something I also want to kind of be really honest about with this is that I haven't looked at this code since I tied it up after the last session. So I'm actually pretty unfamiliar with it. And this is a common thing that will happen if you program or if you make stuff, where you're just like really deep in it at the time, and then a little while later you're like, oh my goodness, what was I doing? I can't remember. So hopefully, like, it might seem like I'm a little bit rusty, but I've kind of done it intentionally, so you can see that it's totally normal that if you come back to a project, you can kind of re-find where you are, and to show you the process I go through when I do that. Okay, cool. So yeah, so what we can also look at when we see this is there's actually a bug, a pretty bad bug, which has to do with the display position. And I'm not sure if I want to deal with that in this session. So I think like there's a few ways you would if this occurred. You know, if you were actually making this game, you want to put it up on the web or something, you'd want it maybe for people with different screen resolutions to be okay with it if it was for PC. But I'm going to be really cheeky, and I'm going to say, actually, let's just say this game is only for 16 by 9 screen. So that's like the standard high definition screen. It's like a TV screen and stuff. And this way Unity just kind of respects that ratio. And this would be, you know, if you're making a game for a specific device. So if you're making a game for like a PlayStation or for Switch or for a specific kind of phone, then you would know exactly what aspect ratio it would use, and that way you could just stick exactly to it. So because I've done this, I'm just going to cheat, and I'm going to move my tools over to the right. Last session there was a really good question about why I'm not using, I'm in runtime, whoops, there we go. Why I'm not using Unity UI, and I think like this is a really good problem that Unity UI can solve, and it can like kind of lock things to the side of your screen. There are other ways around it programmatically, but for now I'm just going to keep it to the same screen resolution to make it easier. Okay, cool. So let's get some watering can action happening. So we'll have a look at that tool code again. And I think actually I'm going to cringe when I reread it. Like, I don't think it's very good code, but that's okay. I tend to work in the sense that I make things kind of functional, and then I'm like, oh, why'd I do it that way? And I rewrite the whole thing and change it all. Okay, so at the moment we have a selected tool, which is static, so there's only ever one of them. That tracks what we've got selected. And then we have a cool utility function that checks if we're clicking on a game object. So we check, are we clicking on this game object? So that's this one that the script is attached to. And if it is, then we select it, and selecting does some logic. So it goes, if we're changing a tool, so if it's not this thing, so if the new tool is not this tool, then we're going to change some of the UI stuff, so make it, you know, it scale up and scale down, and then we have this kind of deselection thing. Okay, cool. So at the moment, the tools themselves don't have any cool logic. This script is really just handling the UI of how it looks, and then in the dirt. Sorry, the other dirt top, this is handling what's clicking it. So if we look at that script, it goes, okay, cool. If I've been clicked, check what tool I've been clicked by. This actually means like check that there is a tool set. If there's no tool, then something funny is going wrong. And then we go, okay, if I'm being clicked by the shovel, this happens. If I'm being clicked by the seed, and the sprite is a certain state, so the sprite is a hole, then do this. Then, you know, turn it into a mound. Now this is quite like a hacky way of doing this. But I think it's totally, like, it's fine for a really small prototype or something. What you would really do if you wanted to be kind of, I guess, structuring things properly is you'd use these things called enums. I don't know if I want to inject one now because I don't really want to rewrite code. Like, I don't want that to be this like session. I just want to make new things for you. But if you're interested, you can look up enums, and they're kind of a little bit like a list of things. So let me just quickly, I'll put in an example maybe, I think. So there's a few concepts I have to add just to talk about enums. Actually, no, there's not. That's fine. Actually, I can just pop one in here. So I could put in here actually no, let's put it in the tool select. Let's put it up here. So for tools instead of for the state of the dirt. So I might just declare a new type of enum. So it's not like it's a variable, it's like a whole new type of thing. It's the same way that we're declaring a tool. So like, here's a tool, select class, here's some information about it. This is like, here's this enum thing. Let me tell you about this enum. And this is going to be like maybe tool type or something. So it tells us like what kind of, it's going to be like a list of things that the tools can be. So, and I'll remove this later. This is just to show you what enum is. So we've got obviously a shovel. Should be, sorry, oh no. What am I doing? Shovel. And no, it isn't quote marks, sorry. That's my brain being slow. Shovel, and we've got a watering can. And we've got a seed, obviously. Cool. And you can see that it's got these kind of curly brackets thing going on, and this is if you've ever seen arrays before. If you've seen explicit definition of arrays, that's what that is, kind of. So enums are kind of like arrays, but what it really does is it turns, the computer takes these words that to us as humans mean something really important, and it goes, these are now numbers. So it assigns these kind of behind the scenes secret numbers, and it was not as simple as like this is what it's assigning to it. It's a little bit more stuff potentially going on in the background with the compiler, but the computer is like, okay, these are just these numbers, so it doesn't have to think about the words. It doesn't really care about that. But for us as humans, we can go, okay, great, so this object, let's give this this tool. So down here where we've got the variable definitions, I'll add a new one. So serialized field is, again, as I mentioned last time, it allows us to see the variable pop up in the inspector. So it should pop up in here. Or in the case we're looking at tools, so it should pop up in here. So I'm going to make a new thing, and I'm going to call it a type of tool. So instead of being like a vector 3 or being a tool select, which is this kind of object, or being a strings like a word, or an integer like a number, it's actually a tool type. So that's its type of thing. And then I'm going to give it a name that's just like, I don't know, current tool or something, current selected tool, which is pretty much like I'm kind of mimicking this behavior here, basically. Not current selected, sorry, it should just be this, like, let's just call it tool type again. It's a little bit boring. And this is something, if you're not familiar with code, you might be like, what's going on with this capital and that one's lowercase? Like, why are people doing this? And basically, it's the capital, and it depends on the language you're writing in, but generally speaking, kind of from C and like C# and a few other languages, it's quite common to have this style of putting anything that's a type of thing. So it's not a specific one of them, it's just a type of thing that exists that you can kind of, like a blueprint you can call on. It uses a capital at the beginning of it, and anything that's a specific one, so there's only one of them or it's a particular instantiation, it uses a lowercase. This is a way of saying there's a thing that's a tool type, I'm calling it tool type, but it's a type tool type. So it's kind of duplicating, that's doubling those words. And I know something when I was starting to learn to code, I was like, I don't know what's going on, I'll just copy what they're doing. But that's just like, yeah, this weird like habit a lot of programmers have. And it makes it really clear as well if you have something in it, you're like, oh yeah, obviously it's a tool type because it's written as tool type. And there's not very many cases where you do it exactly like this either. So I'm going to leave that just blank, and if we pop back into Unity, it should pop up with the selection serialized field, and you'll see it's actually a drop down, which is pretty cool. So it seems kind of weird because it's like, why wouldn't I just store this as a string? Like, why not just have, sorry, wrong one, string tool type? And so that'll compile, and we could just type in, for example, the word shovel now. And it's actually just to prevent human error. So it's just to make it easier for you as a programmer to know that for sure, no matter what, this variable, this tool type variable, has to have one of these in them. So that's like it's a tangent, but like this is a thing I would do if I was going to do this properly. I would like use enums in order to like kind of lock out certain stuff. Like what I'm doing here with the checks on dirt is like a little bit cheeky. I'm like checking the name of the object, but you could imagine at any point in time. So this is getting the current tool and it's getting the name of the current tool from the game object. So it's actually going to like, oh, let's get like this object here, so the shovel, and then it gets the name of the shovel. But you could imagine someone might accidentally duplicate it and like put a new one in, it becomes shovel 1. And now my code wouldn't work anymore because someone renamed it. So it's a way of foolproofing that kind of stuff. And there are other ways to do it, but yeah, Enums is one solution to it. Okay, so tangent over. I'll leave this in here so you can see it in the comments for this when it's all compiled up, but when it's all packaged up and put on the internet. But I won't actually put it in, I don't think. Okay, great. So we need to work out how to make the watering can go. And I think what I actually want to do, there is like a behavior change I want to make to tools. I want to see if they're selected, they follow the mouse around, because I really like it when that happens. And I think it's kind of cool that like you click on it and it gets bigger, but I actually really just want to like have my mouse basically be the shovel, and then I feel like I'm shoveling the dirt. And you can add like little animations into it, so you click and it shovels, stuff like this. It just feels a bit nicer. So in order to do that, I'm going to add some code into the tool select. Now I know when it's selected, I know when it's unselected, so I can quickly probably jerry-rig some code in here to basically say change some behavior. So what I might do is make the follow code work in update, and then I'll make it only work when it's selected. That might be the easiest way to do it. So how can I have my nice little shovel or my watering can or my seed, how can I have that follow my mouse? And if we look at what we know we can access and change everything that's visible here in the transform property. So we can obviously change the position of stuff, right? So we know where we should put the information, but what information do we need to get? And the information we need to get is the mouse position. So there's a few things in Unity with like the input system. So we've got here like a mouse position, but if you can read, that's a little bit small, but it says the current mouse position in pixel coordinates. So that's not actually super useful to us in a certain way, and we'll see why. So if I take this mouse position and I just plug it, say, straight into the current tool, the selected tool. So I'll just say, if there's a selected tool, so again, just checking it exists, because if we don't have a selected tool yet, the computer will be like, oh, what am I doing? I don't know what I should be doing with this. So if there's a selected tool, we're going to get the selected tools transform.position, and we're going to say that equals the mouse position, right? So it's like, cool, just make it so that the selected tools position goes to the mouse position. Now, this is going to cause all sorts of bugs. It's going to be great. I'm actually really excited. So let's go. Let's see what happens. Okay, selected tool. Oh my God, where'd it go? Where are you? We can see the number changing. So up here, the number is absolutely changing, but it's bizarre. Like it's not at all correct. So if we actually pause the game and we go into the scene view, where is it? Let's hit F. Oh, there it is. Okay, so zoom right out. Where is that in space? I don't even know. There's the rest of the scene. Oh my goodness. Okay, so it's all the way up there. And I think if I was a little bit cheeky and I move the game scene down here, so we can actually see them both at once, you'll see as I move my mouse around the screen, it's actually moving around this huge space inside like the game area. So we need some way of kind of figuring out, like we could do the maths. We could go, okay, well the screen size is X amount of pixels and the scene size is this many units in Unity. So it has this idea of width, like, and we can tell it by the position. So we know like the left here is kind of 0 and the right side is like 15. That's what it looks like. So we could kind of like crunch the numbers and do some maths, but Unity kind of already has us covered. There's actually a cool function we can do that transforms the position of stuff. So I'm not sure if I can remember off by heart, and this is like one of those visibility things of like there's no wrong or right way to do this. I tend to just forget stuff all the time when I program. I'm like, I do some stuff, I'm like, I know I can do this, and then I'm like, how do I do that again? Because I know I can do it, I'll start doing it, and then as soon as I hit a roadblock, I'll just Google and I'll be like, tell me internet, what do I have to do? So I'm gonna do a little Google of transform coordinates Unity, and we'll see what comes up. Coordinates, there we go, Unity. And here we go, transform.position, that's not quite right. Transform local point. Oh, this looks good. Transform point. Let's see. So we'll read what it has to say. Transforms position from local space to world space. Cool. So if you haven't heard of those terms before, local space and world space, local space is basically, if we jump back to Unity, local space is this idea, kind of relative to certain objects, the world is a little bit different. You could imagine if the shovel is looking at this world, if the shovel is looking down upon our fields, right? Just as a weird, just go with the thought experiment, just go with it. Then from its perspective, actually, like, a few meters below it is where the first dirt is, and it can kind of see across to the edge of the horizon. Conversely, if one of these mounds is looking at the world, above it is where it sees where the shovel is. So when we talk about local space, we're talking about things that are from the perspective or from the position of the thing we're talking about. So the local space of in the local space of this dirt mound, for example, the shovel is X amount of units above it, and from the perspective of the shovel, the dirt is X amount of units below it. Now, this is different to world space, which is what we tend to see up in here. Now, the one thing that kind of demonstrates this the best is the way as soon as you have parents. So, from the parent's perspective, its position is here, or is it actually? Sorry, its position is here, and as soon as I move it around, so its transformed position is changing, but actually its children don't. So this was always at about 0.2, and even if I move the transform across here, the parent transform, so it's at 7 now, the shovel is still at 0.2. So from the shovel's perspective, it's like it hasn't really, like, its parent has moved it, so it's like, oh, my siblings are all here next to me. It's all kind of this, like, if it was reporting back up to its parent, it's like, oh yeah, I'm at the same position I always was, but the parent has moved around. So you can imagine it almost like kind of solar systems and moons, where like the sun is like the parent, and then the planet is the child of that, and then moons and stuff are the child of planets. So there's that kind of relationship. Anyway, we've talked about that a little bit before, so let's crack on with this. Okay, so we have this cool bit of code. Let's just check that again. So it's got, Unity's nice, has like these little examples in here. So if you're not sure what to do, you can always just copy sets of code. You can look at what it's doing and be like, oh, that seems appropriate for me. So it's instantiating an object. I don't want to create an object. If you don't know what instantiate, it just means to create. I don't want to create an object, but I do want to understand this idea of like an object to the right of the current object. So that seems interesting to me. So to the right of the current object. And that's this thing here, the position, and this transform that's happening. And actually, I think now I'm reading this is not quite right. So this is more for different. So if we wanted to get one object relative to another, it doesn't actually think about screen space. It doesn't give us any information about how the mouse can interpret stuff. So let's just add that into our Google search, and that will come up with something a little bit more relevant, I think. So transforms, that seems pretty much, someone's got the same question. How do I do this? What do I do? Oh, and there's our thing there. You can see I've visited it before. Screen to world point. This is what we want. So where in the screen can I get a certain world point? And I think it is just this one line, and you'll notice it's going through the camera. So where the last bit of code we looked at it was like a object's perspective. We're now like, okay, hey camera, you understand pixels and the screen and the mouse, whereas nothing else understands that really. Dear camera, can you please help us work this out? So I'm going to copy this bit just to make it a bit quicker to put into our code. So we'll copy that in. Cam, it doesn't know what cam is, so I'll have to just be like, whoops. Camera cam equals camera.main. So camera main is basically the main camera. But if I wanted to do this, like this is actually very cheeky. Other Unity programmers would look at this and be like, bad, don't do that. It's a little bit expensive, which is why expensive in terms of like more calls. The CPU is doing a little bit more work in order to access this main camera. But that will basically say, hey, what's the current camera that the world is using, which is this camera up here, this main camera. The other way of doing it, which is maybe a bit nicer, so maybe I'll do that. I'll do it a nice way, which is to say, okay, we have a private variable called camera, and I'm going to call it main cam. And then instead of putting that code in here, that camera reference, I'm going to put that camera reference into our awake function, which we might not actually be using. Okay, so I'll make the awake function. So if you didn't see that last time, Unity has a whole set of functions that you can that exist, and they get called by the engine, but we get to fill in what they do. So this is one of them, is the awake function, and it runs before basically pretty much all the other functions. And I don't need to redeclare a camera because I'm actually going to save it into this main camera slot here. So I'm saving that in there, and I'll put a little note that we're doing this for performance. Save a reference to the camera for performative reasons or performance reasons. Performance. Never judge me by my spelling, please. And then in here we can say, okay, main camera, screen to world point, and then it wants in here, so if I delete this stuff, I think I showed you this last time, but it's like my favorite thing to do ever. When you make a new function, you're like, what do I have to put into the brackets? I don't know. Just retype the brackets, and then it comes up, if you're in Visual Studio, it will come up with like what it expects to be in there, what type of thing. So it has two options. One is just the position, and then one is the position and the mono or stereoscopic eye, which we don't actually care about for what we're doing. So mono or stereoscopic eye will be for like if you're doing VR or something that might require two monitors or two screen outputs that are a little bit slightly different positions, because it's like if you imagine you have so VR obviously has two camera renders for each eye, kind of. It's a bit more complicated, but there's two different renders for each eye. Because in the real world, our eyes are a little bit of a different distance apart. So that's kind of what that's about. So the position we're going to put in is, so my main camera, screen to world point. So we're going to put in the mouse position, screen. So it's screen to world. It's not world to screen. If it was world to screen, so like say, for example, we wanted to, no, right, we do want to do that. We want to make the thing move. So we want to actually switch this around, do world to screen point. No, we don't. What are we doing? Screen, yes, screen to world point. I also do tend to get confused about what I'm doing. Like, what is this? How does that work? Screen to world point. Screen to world. Yeah, okay, great. And then what we could do is we could just replace that in here. So replacing the input mouse at the end of this. So we're saying, okay, get the current selected tool, move its transform position to the main camera position. The main camera's interpretation of where the mouse currently is. Sorry. Okay, let's try that. See what happens. Oops, I got my game down there. Oh my goodness, this is not right. So let's just click on our watering can, see what happens. So the watering can is like kind of at the right point, but we can't. So it's going between 0 and 16, which is what we said before is kind of the right size, but it's disappearing. It's like, what's going on? So again, let's just like have a look and debug. It's all the way up here. So let's just see. Let's get these both running at the same time. Again, and I'll unpause it, and we can see, oh, it is actually following the mouse, but it's kind of invisible for some reason. That's super weird. So what this could be, what it probably is, if we jump into 3D, so we just clicked on that 3D 2D box, see that basically the watering can is like super far in front of everything, which means if you look at this, so here's our camera here, that's our camera, it's actually, I'm trying to think how to like pause this at the same time. I think if we get it lined up right, so I jump here to get a perfect view of it, or almost perfect. It's actually exactly on the same point as the camera. So that's probably why this screen to world point, it actually wants a vector 3, so it wants 3 coordinates, and the mouse position only has 2. It's it says it's a vector 3, but it's really just 2. It's like it's the X and the Y. So the easy solution to this is to just add on, or actually there's 2 ways of doing it. One is we could add on some number, so we could be like, okay, add on vector 3 forward. I'll just check if that's the correct direction. I think it might be, actually I need backwards, I think. Backward, or back, sorry. So that vector 3.back, like I think we talked about colors last time. Did we talk about colors? Maybe not. Vector 3.back is just like, there's a direction that is back, and it's basically negative Z, and that's it. So Z, you can see here, Z depth into the screen. And if I hit play again now, I'll test it down here with a shovel this time. So it's still not visible. And we can see it's done, it has gone the wrong way. I was right the first time. So that's one way we can solve it, is we can kind of add a number back onto it in order to move it in a certain direction, which should make it visible. Pardon me. And since we're using an orthographic camera, we don't really see, like, the depth doesn't really matter. So long as it's in front of the camera, we're okay with it. So now we can see it works and looks pretty good. You might also notice, if I just change this camera so you can see that a bit nicer. Zoom this in here. You might notice, so this is still a perspective camera of the scene, a 3D camera. The shovel is kind of 3D wise, it's in front of the dirt, but then like it's actually behind the dirt in the scene when it's drawn, and even when we look at it from the front of the camera, it's behind. And that's because when we have sprites, they render using their order in layer, this thing here. They render in a different way than normal 3D rendering. So this idea of like how we interpret 3D space as human brains is like sprites are just like, oh, whatever, and they have their own style of doing things. And there's some strange behavior you can get if you don't follow the kind of the rules involved. But for the most part, for sprites, just always make sure the sorting of the order and layer is correct. So we had a question from Sid Doctor Zero. Sorry if I'm saying your handle wrong. We're using C#. So C# is a language of Unity, and I think that it used to use, I don't know if it still supports it, but it used to use Unity script or Java, like basically a kind of weird version of JavaScript. Let me see if they still support that. C# script. Maybe not. Maybe you can't. Maybe you just have to use C# now. You could use like this weird JavaScript a long time ago, but it was a little bit horrible. It had lots of, I mean, I'm on my programmer high horse basically, where like JavaScript is okay in some circumstances to learn, but it also kind of can teach you bad habits when you're learning to program. Okay, cool. So we now have a following, which is good, but I think I'm actually not really happy with this, with just moving it forward a bit. I really want it to stay aligned in the right position, just to keep things nice and clean in our scene. So I really want a way of making sure that we keep it aligned to where its original position was. So what we could do is actually save the original position. So I might go vector3 original position, original pos, and I'll make that equal to the selected tool transform position in here. And then what I can do afterwards is, so instead of, so we're putting this new, actually, let's switch this around. Let's call this the new position. Okay, so new position is equal to this bit of logic we did here, which is getting the position of the screen. And then we're going to say, actually, to the new position, I want to make its Z, so its depth value, I want that to be equal to the original. So I'm overriding, so whatever the screen has given me, I'm overriding that back with its original position. And then I'm going to say now be equal to the new position. So I'm actually putting this little extra step in there that just goes, oh, whoops, that needs to be .z. There we go. I'm basically saying get me the position from the mouse, get me the position in the world from the mouse, and then override the Z position, so the depth of that, to be what the current tool is, and then set the current tool to be whatever this new position we've made is. Yes, correct, similar. It is in perspective, and that was kind of what I wanted to demonstrate is to show that the rendering pathways are a little bit different. So as soon as we pop back into 2D mode, it will behave as we expect, which is fine. But I really want to just show that there's this depth that can happen, and if you're working in 2D, just be really mindful that even if your camera is set to 2D, there's still stuff happening kind of in 3D, and it can have some strange impacts on your game sometimes in sprite rendering. So like if you have multiple things on the same order in layer, maybe it will use the 3D depth of the object to render it, but maybe it won't. And if you're not tracking the 3D depth of the object, some weird stuff can happen. And it's just a little bit confused. Like even here we've got like, these are not aligned right, but there's just some weirdness that can occur with Unity because the 2D system is kind of, it was added a little bit afterwards, and it's really just like a jerry-rig of the 3D system. Awesome. Okay, so let's just check that this works. Yes, that looks pretty good. Cool, we can click. Oh, but if we change objects, it doesn't seem to actually update and change. Something weird is happening. You see that? Something very weird is happening. So I recall that we did actually do some cool code that said that you can't click on one of the tools if it's already selected. I think we disable the collider, so let's just check if that's the case. So I've got, I'll select the shovel in here so I can just see its options in here. And if I select the shovel, then it disables its box collider. Awesome. So when I'm clicking on this, something weird must be happening where it's like it's kind of double, it's like selecting something else and then deselecting it and then it's moving it weirdly. And that's because this kind of bit of code here, even though it functionally does some of the steps that we want it to, it's not at all like the right place to do it, kind of. It's not really the logical place. So what we really want to do is, like we could do this, I think if we have one tool selected script that handled everything, this would be fine. But because we have 3 tool selected scripts, what's actually happening is that every single tool selected script is running through update, and each of them, so we have 3 of them at the moment, one on shovel, one on watering can, one on seed. Each of them is running this code in update. Each of them is like, hey, selected tool, let's do some stuff with you. So what I really want to do to make this a little bit cleaner is instead for each of them go, hey, am I selected? If I'm selected, I want to have this certain kind of behavior. So we could go if select, we could even just say if selected tool. So if there's a selected tool, actually an easy way of swinging it might be say if selected tool is this tool. So if the selected tool is this, so it's this script, because selected tool is a type of script, which is the tool select script. So if the selected tool is this script, then we're going to run this code. So let's see if that makes a difference. There's still a bit more we'll have to do, but let's see how it goes. Weird things still happen. It's a bit sad. I like how they're moving. They're definitely moving to the position of the mouse, but only for like what looks like the one frame. So they're not able to select themselves for some reason. So let's see. If selected tool is this, then we run this code. So I think that's okay. And then we need to check what order it's all doing this stuff in. So I kind of want to know, let's do a debug log. So debug log, just so you know, trying like selecting tool, and then I'll just put in the name so I know what object it is. And I'll put one in the deselect, so deselecting tool name, and that way I can tell what order is happening when I try to select a different tool. There we go. Cool. Okay, wait, I just wrong. My brain was somewhere else. Still doing the same thing, but right, we can see what's happening in the console. All right, so let's just try it again because I clearly was daydreaming somehow. So we select the seed. Cool, so we select the seed. Let's select the watering can. Okay, so it says deselecting the seed, selecting the watering can, deselecting the watering can, and selecting the seed. Okay, so it's somehow doing both at once, which is exactly what it looks like it's doing. So it's selecting the watering can and then selecting the seed again. So it might have to do with the order of operations here, which is to say that for some reason after it's selected the tool, it still thinks that it can check for another click. So it could be that our little script that goes is clicked. So if we actually go to that, go to definition. So it checks if the mouse button is down. We could switch this to up, and this might actually help. So mouse button down is when the mouse button is clicked down. So in the frame that the mouse is clicked, like the mouse goes from being unclicked to clicked, is mouse button down. Mouse button up is the frame that the mouse goes from doing the opposite. So the mouse was down and now the person who was clicking it has released it. So, oh no, still being a bummer. That's a pity. If you have ideas out there in the world, go for it. Let's see. So This is probably because I haven't really written this properly. These funny little things can happen. So when we select something, we go through this process. If the selected tool is null, then we deselect it. If it's not null, then we deselect it. Then we select it. So it's definitely because it's being selected when it shouldn't be able to be selected. So if this object is clicked, so it could be that the update is happening. There's like a really cheeky thing we could do, but it's really hacky and it makes me a bad person, basically. And I could just do a little boolean that says if you've selected a tool this frame, then you can't select another tool. That's something you could do. But I really want to know actually why it's behaving this way, because it shouldn't have a collider on. The collider should turn back on after the raycast here is done. Because if we click is clicked, should happen after. So, but it might be that maybe the update is run afterwards and then it's still detecting the click at the same time. So actually what we could do, maybe the best solution is this, is that actually the collider turns back on a frame after it's been deselected. So we actually put a little pause in there on it. There's lots of different ways you can solve these kind of funny problems, but I might do it just so I can show you coroutines. Oh, and it should be back to its home. Yep, that's a good call, actually. Let's do that. So Simulith says when you select a new object, the previously selected object should move back to its home base so then it doesn't get hit again on click. That is by far the best solution. Thank you. That is so logical. I don't know why I didn't think of that. Easy. So deselect has to send it back to its home base. So instead of it just turning on the collider on, it actually moves it back again. I think maybe I kind of wanted to have demonstrate that problem and have all the tools like left all around everywhere in weird places, so you could be like, how do we solve that problem? But let's just solve it now rather than like demonstrating it. So the first thing we need to do is have this idea of a home base, like where is it that it lives? So we could, like, basically the easiest way to do that is like we did here with, on the awake where we save in the main camera reference, we're going to save a version of where our original position is. So this is going to be another private variable, another vector 3 because the position. So private vector 3, I call it original position, just like that. And in awake, we're just going to take that original position and we're going to put in the transform.position. So we're just saving in where it was when we started. So it'll just, whatever the position is in here when the game begins, that's what's going to get saved into that variable. And that means when we deselect it, so before we enable the collider, we are going to make the transform dot position equal the original position. Just like that. Let's see if this solves the problem. I think it will. There we go. Perfect. Thank you, Simulith. Brilliant solution. And I actually think with this style, we don't actually want the scale up change. That feels a bit gross to me. It doesn't feel right. And there's something else we might want to change, which is that we should probably notice then is that the objects kind of go behind each other. Like they all have this order, the sprite order. And we might want to make it so that when you select an object, the sprite order pops in front. So let's disable this local scale stuff, because I'm not into that aesthetic right now. And it also means we don't need this selected scale. Sorry, selected tool, selected scale, this one here, this serialized field, we don't need that. But we do need to put another reference in. So we're getting the main camera and remembering that, making a reference to the main camera. We've got a reference to the original position, we're saving that. And now I want to get a reference to the sprite renderer. And again, it's the same reason as before. We just want to be really efficient when we're doing stuff. We don't want the computer to have to be like, oh, where's my sprite renderer every single frame. If it just has a reference to it, it can do it much more quicker. So we're going to make a new private variable. This is a sprite renderer. I usually call it like sRenderer or something. You can call it obviously whatever you want, but try to use something sensible so you know what it is. And that's going to use this thing called getComponent, which I think we did before. Have we done getComponent before? yeah, get component collider. We used it with that. So same call as that, get component, and it can be anything that's a component in Unity. So basically anything that can be attached to a game object, you can use get component with. So get component that. Awesome. And then we can also do this. This is just to be nice and safe. A private integer that's going to be the original order in layer. So original order in layer. And we'll do the exact same thing. Now that we have a sprite renderer, we can say original order in layer equals sRenderer dot sorting order. It calls it sorting order. So maybe we can just, in code, we'll just call it sorting order. That makes it a bit more like the code version. Although actually that's a bit confusing. So original sorting order. There we go. Original sorting order. And I think if we actually check the tools, they probably all have the same sorting order or order in layer. They're all on 0. You can see there. They're all on 0. So what we can do, because we know that, and like a designer could come in and change that if this is a bigger project, but we're just going to be like, we know that that's a fact. So when we've selected the tool, when we know we've got the selected tool, and we turn off the collider and all the other stuff, we're going to go so sprite render. So I'm directly accessing the sprite renderer through the reference that we made, and sorting order equal sorting order plus even. I could just do that. So what plus does, if you haven't seen that before, is it's shorthand for writing. If I write the whole thing out again, sRenderer dot sorting order plus equals 1. If you haven't seen that, that's shorthand for writing sorting order equals, and then I'm just gonna I should have done this to begin with, just copied it, copy and paste plus 1. So these 3 lines are all the exact same thing. The term for this operator is called the increment operator. So it just increases it by a whole number. The inverse of it as well is minus minus. So if you want to decrease by 1, you can do minus minus. That will bring it backwards 1. So let's add that there as some comments. Cool. All right. And then we just want to make sure when we deselect, of course, it goes back to its original one. So we'll take this same set of logic and we'll say equals original sorting order. Now, you might be thinking, why don't you just write something like this? And I think if you were really sure about your code, you could be like, I know that every time I select it, I'm going to deselect it. I can use that kind of logic. But there are weird cases where that might not happen. Like what if you have a pause menu and the pause menu causes the deselect to run because you don't want the player to exit the menu and have something selected, for example. But the pause menu might have some weird behavior that then means that this doesn't ever get incremented again or something. So even though kind of logically you can go, well, the select will increase and then the deselect will decrease, there can be cases where just weird stuff happens. And so a way of and it's not necessarily, like it can be bad those things happen, it can be good to catch them that way, but it's just much safer generally to go, actually, let's just make sure one of these always goes back to the number we know it can be, if it can be. There are cases where maybe you can't, and you have to have a stack of information that a little bit more complicated, like an array or something going on of information. But generally speaking, if you can use like a solid number, try to use a solid number where you can. Okay, cool. So let's see if that fixes that sort order issue. That looks good. That looks good. That looks good. Awesome. And that also means, oh look, it's in front of the dirt, but not in front of this dirt. So we can jump onto that dirt down there, the dirt patch, and we'll put that back at like 1. I'm just going to save my scene. Okay, and then let's actually make some plants grow. Oh my goodness. Great, so the watering can. So now we have this idea of the objects themselves can do stuff when they're selected. So if I was going to do this like in the best way possible, I would probably use there's a few ways you could do it. Like one is you could put like an if statement in here. So in here we've got the selected tool equals this. This is where we can start putting some bespoke logic in. So it could be like if this so this and the selected tool, because they're both the same, we already know they're both the same thing. If this is the watering can, or even like if name equals watering can, we can start putting some bespoke information in here. But what I might do, maybe this is a bit overkill, and people might be like, what are you doing? Is I would actually use object-oriented behavior. So I can't remember if I mentioned it last time, but there's this idea that mono behaviors are the base class for everything, and this little thing is like an extent, like says that tool select is a type of mono behavior. So what I would actually do, and it's a little bit of a restructure, and I do tend to do this halfway through programming a lot, happens a lot, where I'll just rename things, and then I'll have to go through and fix all these compile errors, which gives me a really good idea of where everywhere that object touches. So if I do that for now, for example, so I'm going to rename this to tool. So a lot of things are going to freak out. They're going to be like, oh, what's a tool? I don't know what a tool is, because tool select is it's now called tool, and tool select doesn't exist anymore. So a few other things might break. There we go. But this shows me everywhere this code touches, right? So I can work out what's going on. There we go. So I'll say tool, get current tool, if the current tool is blah, then do this. Yep. So what I might do actually is, so I need to rename, one important thing about Unity, I think I mentioned this last time, is that the script, the title of the script up in here needs to match the actual file name for a class. So I'm just going to make sure that's called tool as well in here. And just as a side note, never, ever, 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 unless you have to, never change things in the file structure in your operating system. If you do that, Unity will absolutely be like, oh, what's happened? It will not have any idea of what's going on. But if you changed file names and stuff in the project view, that's totally fine. Like Unity will be like, okay, cool, you've changed that. I'll update all the references I know about it. Same thing with like, if you, there we go. So now it's like reload because the name has changed, which is fine. But if you say, for example, even if you're like, I'll just tidy my folder a little bit and I'll just like move my scripts into the blah folder, that is like a super bad idea. Don't do that. Unity will get very confused if you do that, and you'll get, and same with like if prefabs move around, you get all these broken links to prefabs and things won't load in, and it's just like all around tears basically. Cool. So where are we at? So what I would do with these scripts is I'd use this thing called object-oriented behavior. So or object-oriented programming. So people might have heard of OOP, or we just like OOP like this, object-oriented programming, object-oriented programming, or like an object-oriented programming language or whatnot. So there's quite a few of these. They're basically like C++ is kind of the really, really big one. So C is not object-oriented, but C++ is. Java is object-oriented. C# is object-oriented. There's like a bunch of others that I can't even, like off the top of my head, I can't even think of. And they all use this technique of this idea that like certain classes or certain sets of code will share similarities with one another. And that's exactly the kind of thing we're facing now with the tool at the moment, where all the tools have the same behavior in the sense that if I hit play and I select them, I want them to follow the mouse. But when I click, I will want them to do a little bit of a different thing. Like I want the shovel to do like a scooping animation, and that could just be like, here's a different animation for it. Which is a really good way of doing it. But actually in the case of like, say, clicking the watering can, I want it to tilt over and then for it to make a sprite appear and then to make water fall out of it. And there's like all this extra stuff I want it to do. So it's like where I'm saying, like if it was just an animation difference, like this just does a tilt animation when it kicks up the dirt and this does like a tilt over animation or something, that would be okay because it's a thing it has. Like it has an animation, so it's easy to keep it as one single class. But as soon as it's doing a different behavior, it's doing something that's intrinsically different, then I can start branching this out into different classes. So what I'm going to do is I'm going to make a new script and I'm going to call it watering can. And I might do this for each of the tools. I think it's probably the cleanest way to demonstrate this. And instead of it extending from mono behavior, I'm going to make it extend from tool. So you can imagine it as a chain of things. This is kind of secretly saying in the background, it's basically like this is also a mono behavior. So it's extending kind of from this big chain of stuff. And I think mono behavior extends from like something called objects, right? They all extend from this big long list of things. But when you actually write it, you just write the thing that it's the one, like the next thing up the chain, and the compiler will figure out all the rest. So what it means is if it's a tool, and actually I'll remove this, so it's just an empty class. And I'm going to go to the watering can tool here. I'm going to remove its tool script. I'm just going to get rid of that. I'm going to put the watering can script on it. And even though it has a different script, so even though this is a tool and this is a watering can, if I hit play, it's still going to behave exactly like it did. And that's because a watering can is now a type of tool. And Unity is like, oh yeah, okay, cool. So a watering can should always behave like a tool unless I get some other rules on top of that. So let's start putting some new rules on top of that. So at the moment, the selected behaviors are all pretty generic. They're fine for all of them. What we want is for something different to happen, maybe on update or maybe on, yeah, maybe on update. So let's see, get current tool, that's fine. Yeah, all this stuff is pretty much going to be the same. So a different point will be an update where I want to say if the player is clicking, I want the watering can to tilt and I want some water to come out of it. That's going to be my key difference. And you can write all this stuff down like a big diagram, or you can just write it down to get out of your head first, put it in either the graph form or just in words or in pictures, whatever works for you. You can write it down, or you can just code it straight in if you kind of know what you want to do already. I tend to write I just write it to get out of my head, and then it really helps for me to have my brain look at the words that I've written down to reinterpret them. So I still want it to do this stuff that's in update, but I want it to do a little bit more on the end. So there's a bit more you'd call this extra code that I would have it do. And I think maybe the nicest way of doing it, there's two ways I can do it. So I could say if this is I don't want to duplicate this selected tool thing, so maybe I'll make a new function. I'm going to call this void, maybe tool update, or use tool or something. Actually, you know what? Yeah, I know what to do. I'll say if the mouse button is down, then do something. So if input mouse get mouse button 0. So that's just, so I said earlier that mouse button down is the click down, mouse button up is the mouse up frame. Mouse button down just means every single frame that it's held down. So if the mouse button is down, then I'm going to say maybe do tool action or something. Do tool action is what I call it. And then here I'm going to write a new virtual void class. Virtual void do tool action, like that. And it's going to be empty. Oh, sorry. Okay, has to be protected. Okay, so this is a new type of thing we haven't seen before, and this is a new type of thing we haven't seen before. So we've talked about private earlier. So private is this idea that only this class knows about it. So only this one script that I've written knows about it. And public, if we have a public thing around here somewhere, I don't know if maybe in the dirt we have a public variable. Oh, we don't have any public. If we had a public one, it would be open to everyone. So I think actually maybe selected tool is public, because this can get the, oh no, I have a get current tool function, so it's a bit nicer. So get current tool is a public function. So I have this idea of public where anything can access it. But in this case, if we go back to our tool, we have this new thing called protected. So protected means that this class can access it and all of its children classes. So anything that inherits from it like this, that has this extension thing, those things can inherit from it. And that's because, as we saw before, the watering can is behaving exactly the same. So there are cases where I kind of don't want the watering can to have access to certain things the tool does. So for example, I don't want the watering can to be able to override the behavior of select, but I do want the watering can to be able to override this particular function I'm writing here, because the do action will be different for each of the tools. So I'm just going to call it do action, and it's virtual because it's a thing I'm saying that I want to let children override. So this is saying you can access it, so you know about it, and then this is saying, hey, you're actually allowed to overwrite this if you want to. So to show you that in action, so I can now write do tool action. So the same function, I'll just rewrite it in here, and I have to do the same void thing in here, it will probably give me an error because I have to put this override. So override void do tool action. And in here I can write whatever I want. So I'm going to say do tool action, which is when the mouse is clicked. So I'll put a note in here. When the mouse is held down. Or actually, every frame the mouse is held down. Every frame while the mouse is held down. That's a good way of putting it. It's going to do something. So it's going to... Sorry, just jumping through my code. There we go. I think I might, yeah, get mouse button down. Maybe I won't put it when the mouse is down. I'll just do it every frame. I'll just say every frame. It's not really do action then. It's just do it. It's just call it action. I just call tool update. I'll call it tool update. It's a bit trash, but I'll do that. I have some reservations about it, but let's roll with that. So let's quickly change the name of that. Okay, so I'm going to do that check again because I actually want to have different behaviors based on if the mouse is down or not. So if, again, if input mouse, if input dot, what is happening? I can't, what's that? Hang on. My autocorrect is not working and I'm like, oh my goodness, I can't remember anything. Okay, mouse. Button 0, and I might say get mouse down actually, and I'll make one for mouse up as well. Get mouse up, like this. And what this is going to do is it's going to make maybe some water appear. So this watering sprite we've got. So if we go back to our art, we've got this like cool stream. So I'm going to put this stream into the watering can. So it's a child now of the watering can. So if I move the watering can around, that stream moves with it. I'm going to put that stream, this is going to look really ugly to begin with. Put the stream here maybe. Here, yeah. And I'm just going to say turn on that stream when we do stuff. So when we do stuff, we're going to put a new reference in here, so a serialized field, because we're going to add a reference to this stream, this object we've got here. So new serialized field. So I'm just going to reopen this script because my autocomplete is not working on it for some reason. Okay, so no, still not auto-completing. It's a bit strange. Oh well. So new serialized field, it's game object. I'm going to call it the water stream. And I'm going to say when the mouse is down, so when we press the mouse button down, the water stream set active. I think it's set active. It's weird, I feel like I'm blind. I have no autocomplete. I'm like, is this right? I don't know. Water stream set active to true. So basically turn it on, so make it visible. And then here I'm going to say set active false, so turn it off. And let's just see if that has any compile errors. Doesn't look like it. So I'm going to start it off by turning it off in here. Oh, I do have a compile error. Great. Okay. Let's see. Oh, there we go. Okay. Cannot be private. So it doesn't like that. This is implied as private because there's nothing written on it. And it's saying, oh, you can't make that private because it can still be overridden by other things if it had more children, for example. So I'll make it protected as well. So it will then match with the protected nature of this one here. And then I've written get mouse button down wrong. So let's just check. It is get mouse button. That's what I'm missing. There we go, get mouse button up. There we go. Awesome. And now we can click it. Oh no, and it has an error. The variable has not been assigned, of course, because we never assigned it. So in the watering can, we can now see it has this object slot, so I can put the watering stream into there. And like the other tools that we made, they don't have anything. So even though the watering can has the same behavior as the other tools, it has its own now special behaviors that are unique to it. So select it. Oh, cool. And then when we click, it makes this cool line. So I'm going to make it a little bit nicer just by rotating it. So I'm just going to make a new serialized field that's the rotation amount. Make it a float. If I was going to do this really properly, I'd probably have a different sprite maybe for the watering can. So I might have a whole new sprite of it pouring water to make it look a bit cooler, like on the edge. But we're just using my horrible lazy sprites, so we'll just rotate it. I'll call it pour rotation amount or something like that. And we're going to say when the mouse button is down, transform. Oh, it's so weird that I don't have the autocomplete. I'm actually going to be really cheeky. I'm going to like half write it in here and then I'm going to copy it out. So I can't remember all my function names. I didn't realize how much I relied on this until I had it taken away from me. Here we go. Transform, rotate, around, local, rotate. Local rotation is all these cool things. So rotate around. So applies a rotation of Euler angles in z degrees around the z-axis. So that's into the screen. So that's the right way. It takes a vector 3. So it gives us 3 different ways we can rotate it. And we also have one down here that's just the rotation of it. It's the rotation of the transform stored as a quaternonian. I'm not going to talk about quaternonians. They're really cool though. They're basically like 4-dimensional data types to represent 3-dimensional information. It's very, very interesting. What I might do instead is rotate around. No, rotate. I don't just do rotate. Okay. So rotate, and it will be. Now I know what that function looks like. I'm going to pop back into here. So rotate around, I think it was called. Rotate around. So it took a vector 3. So that vector 3 is how far it should rotate around the x, y, and z axes. So in order to make it, so that means I could either make this into not a float, but I don't really want my designers to have access to something that's not a float because really the rotation in 2D is just around this one axis, the z-axis, right? I don't want it rotating like this. That would look weird. I just want it to rotate on the z-axis, which is like this. So I'm going to say rotate around new vector 3. So I'm making a brand new vector 3 on the spot in my code. And it's the x is 0. I don't want it to change on the 0. And I can just double check what the current rotation is. 0, 0, 0. So 0 on the x, 0 on the y, and then on the z, it's going to be the pour rotation amount. And I'm going to be really cheeky because I know that this is its original rotation. I'm actually going to set it back manually on the get mouse button up, which is a bit cheeky. So pour rotate around. There we go. I could even like potentially set the rotation, but there is some. So the idea is, even though we can think about rotations as these axes like we see here, the whole point of quaternonians and that more complicated data type is because there's this weird thing called gimbal locking where kind of like there are points where these, it's hard to explain, but if this is rotated around kind of this way, oh, I can't even do that right. It's kind of the same as it having been rotated around the other way. And so if you're trying to make like a nice smooth rotation continuously in a circle around some obscure axis, then traditional like just having 3-axis rotation information will mean that it can not work correctly. And you can get some weird things happening in the animation. So if you've ever seen an animation where it's like it looks like it should be a looping animation, but it's a little bit, and it's like rotating all the way around, but like something weird happens and it seems to like flip around backwards or something. That's probably because of this thing called gimbal lock. But for this, because it's 2D, it should be totally fine. Okay, and I've got this error saying that rotate around takes an extra argument, and of course I don't actually have autocomplete on this function, so I'm just going to look up what rotate around wants in the API. Transform.rotate around, there we go. It does just take one argument. Vector 3. Oh no, okay. Rotate around. Oh, so it takes the axis. The axis is the second one, and then I don't want to rotate a point around. Something's not right. Let's see. Transform rotate. I've done something wrong. rotate around. Okay, I don't want to point. That's my problem. I don't want the point. I just want to rotate it. Applies a rotation. So I just want rotate. Rotate relative to. Oh yeah, there we go. This looks better. Rotate the Eulers, the rotation to apply, and then the relative to space. And it actually has a preset space, which is kind of what we want. So just rotate. That should work. And then back here, so just like with the increment and decrement, I could do this, right? I could write this and make it go backwards. But it's probably safer for me to reset the whole rotation manually all the way. So again, the safest way to do that is to so make a new private. So it's a quaternonian because that's the. Oh, you can't autocorrect anything. Can't autocomplete anything. Can't spell. I was talking about this earlier. It's like don't try to make me spell. It's not going to end right. Let's just check this quaternonian. There we go. It's so strange that my autocomplete is not working in this subclass. There we go. Quaternonian. So I'm going to call it original rotation. And we're going to go, again, private, or like avoid awake. And something interesting is going to happen now because we're doing this. And the original rotation equals the transform dot rotation. So we're just saving that in, just like we did with the position for the other tool, for the regular tools. And then here we just say it's equal to the original rotation. So the game starts, we take the original rotation, we save it into this variable, and then when we press the mouse button down, we rotate the tool down and all the watering can down, and then as we release the button, we then rotate it back to its original position. Let's just see what happens when we try to compile this. See if it's happy. Oh, it is happy. That's pretty good. Okay, great. Now what I had thought might happen is we actually also have an awake here. So I'm kind of surprised that the watering can isn't going to, it might get upset when we actually try to play it, because it shouldn't let us have two awakes that don't override each other properly in the same kind of class family. Oh, but it hasn't complained. Oh no, there we go. Oh no, that's the tool reference. That's not it. Here we go. So the pull rotation amount didn't actually set it to anything. Let's make it, let's try 40. I'm not sure if this uses pies or, I said Euler angles, didn't it? Euler angles. So if anyone's not super familiar with like angular maths, Eulers are your 0 to 360 length. So a full rotation is 360 degrees versus radians, which is pi. So 3.14 is is a half circle. Sorry, and Eulers go up to 360, and 2 pi is what it is otherwise. Okay, so what is this reference? Let's have a look. Oh, I can't find an S renderer, so something's a bit funny there. That's not an expected error at all. Oh, I think I know what it could be. Okay, so it hasn't given us an error, but we did something naughty. The awake function in the base class in the tool does all this cool stuff where it sets up all of these references for us. The watering can is very naughtily overriding it. It should actually say override on it, so we know that's what it's doing. I'm not sure why Unity hasn't told me off for that, but it should have this override keyword in it. And what this means is, so we're in our tool update function. It doesn't matter if we override it because this is empty, right? Oh, sorry, you're right. It's Euler. Sorry. Similar is like Euler is unexpectedly pronounced Euler, and that's 100% correct. It isn't Euler. I have a funny thing where I read words wrong and then I can't pronounce them right. They're called Euler angles, not Euler angles. And I'm going to probably never get that right in my life, but I'm going to try really hard for this session. Thank you, Similar. Hero of this stream right now. Okay, so override, void awake, blah, blah, blah. What have we got? Let's see. Okay, so basically we're overriding the awake function, and that means that we're not actually running any of this code in here that we want to have run. So the nice workaround for that is this thing called base.awake, or base or whatever the class is. So this word base is like, hey, you know how we have used this before to reference like this script, right? Base is saying, okay, reference the base, so reference the tool version of this script. And it's still kind of this script, like it's still this version of the script, but it's like think back into your past, think into your history. Who were you before you were this script? And it will actually run this code that we've got in here. So it runs all of that. And that should remove this error we have, which is saying that that the object reference for our, later down in this tool code, further down here, where it expects stuff to, like the S-renderer to have been filled in, that should resolve that issue. So let's just see what happens. Oh, and more compile errors. No. Oh, there we go. Okay, so similar to before, it's like, you can't make that private. So I'll make that protected. Oh, and that's interesting. So it thinks there's no suitable override. Let's have a look. That could be because I made it private here, so that should also be protected. So a weird thing for the privacy was that it couldn't even see that there was that. So this should be protected virtual void. So it's just like this one down here now, protected virtual void. So that virtual word means that its children can override it, and then this override word means, hey, I'm overriding this. So let's see how that goes. And then I think we might have a short intermission, and then we'll like maybe come back and just like wrap up a few things. Yeah, oh my god, but our water is like at this weird angle. Anyone know why that is? See if I can like pause. No, I can't pause it and turn it at the same time. What's the hotkey for pausing? I can't quite remember. There is one. I can show you in the editor anyway. So let's just turn our stream on for a moment. It's our watering stream. I'm rotating the whole thing around. So that's why we're getting that effect that the stream is turned. So I could be very cheeky and I could actually rotate this the other way. Like that's a solution. That I could do. But what I could actually, like maybe a nicer thing to do that could kind of look a bit cooler is on the watering stream, I'll make its own script. So I'll make a brand new script. I'll call it water stream. And I'm just going to make sure that every single frame, I'm just making sure that the watering stream is upright. So this is just going to say transform rotation equals actually I'll save it in a private variable. Private vector 3. I'll just call it like, do I want to call it rotation? Because that's like, that will conflict with this rotation kind of in a way. Let's call it stream rotation maybe. Stream rotation, and I'll make that I know, actually I don't need to do that now I'm thinking about it. Make it vector 3 dot, and let's just see. Oh, it's just 0, so vector 3.0. So the rotation should always be the rotation we see here. Should always be this. And this will not affect it. Oh, whoops, this should be a quaternion. So the equivalent, so this rotation, unlike local angles and a few other things, I could actually set this to be the Euler angle. I did it again. Euler angles. Oh, you're not auto-completing either. What kind of strange place am I in? It's not autocomplete. Oh, strange. Okay, I could set this to be, you can actually write like, I think it's Euler rotation or something like this. But what I could do instead, just to set the rotation manually, is to use the quaternion identity, which is the equivalent to vector 3.0. It's basically saying like the normal, straight up, nothing exciting version about this thing that I'm doing. So I'm going to just copy the word quaternion because I can't spell. And I'm going to call this quaternion dot identity, and we'll see how that goes. And then it wants, why do you, oh, it's a capital T, that should be a lowercase t. So like I said earlier about the types, the capital T Unity is like, it's the type transform, do something with that. Yes, so similar to I said, a better solution here might be to group the watering can and water stream under a watering can group, and then you can rotate it without impacting the water. So what that would mean is making another child object here, so create an empty child, moving the sprite. Oh, you're gonna let me do that, Unity? That's weird. Move the sprite? Okay, maybe not. I'll just copy it. So paste that new component in there. So copying the sprite into there, and then I can remove the sprite component from here. And actually now they would move independently. So I could move this. This is just the sprite. I can move this separately to the water. But the reason I'm not going to do that is because A, I'm lazy. It is a much better solution, but A, I'm lazy, and B, because then we just have to update our little, and it's actually really minor, but we'll have to update this S-renderer reference in a different way. So the sorting order would change for a few things. And there is like a much deeper solution that I probably should put in there, but just for the purpose of this stream, to keep it simple, I'm not going to. And that would be like to sort through, like make an array of all of the renderers and make sure that all of the renderers are kind of incremented up an amount, and then they can all be decremented back down again afterwards if there was this depth thing we wanted to do. But now, anyway, with this script, it's going to kind of counterweight, it'll counterbalance what the parent is doing, and it will kind of reset it to being this 0 rotation when we click, hopefully. There we go. There was that one little frame there of it being a bit naughty, which is pretty funny. And the other thing nice about this is if we add an animation onto the watering can, so if it slowly rotates, like if it does like a boo. Actually, if we do that in runtime, let's just check that in runtime. Hang on. Let me retry that. Okay. If we check this in, if we change the rotation of the watering can in runtime, it always kind of sticks down like that, which is kind of cool. And it's locked to that point on the axis, which is, or that point on the watering can, which is what we want. If it was really fun, you could even use like, say joints or something like this to get like a cool, like little bit of like a sprinkle effect happening. Maybe we should just use joints. Could be something for a future stream, potentially. But for now, this works. So I'm going to set this back to its original rotation, which is about like this or something. And the next thing is now to check if we're hitting a mound, or we're hitting some dirt. So there's two ways we could do it. Either the dirt could check for the watering can, or the watering can could check for the dirt. So have a think about what you want. I think, yeah, we'll have a short break, and then that'll be the last thing we do for this session, I think. So, yep, so we'll have a short break of like 5 minutes for everyone to just like have a little bit of a chill, grab some water, go to the toilet, all that kind of stuff. And then we'll do a little bit of logic to work out like how do we actually check, you know, if we've done this, if we've dug a hole, how can we make sure that we're actually, oh, sorry, put a plant in it, that we're actually watering that section and then have that plant grow from it based on that. Okay, cool. I'm going to see you all in 5 minutes. So at 37 past or so, depending on your time zone, I suppose. It could be 7 past. But I'll see you all in about 5 minutes. Hello. We're back. It's been more like 4 minutes, but that's okay. Short little break. So we were, for anyone who's just tuning in or missed kind of the beginning of this, we're making a little plant game. So far our behavior is, let me just maximize it. You can click on different tools, and then you can click the dirt, and then you can plant a seed in it. And then you can, we're now getting to this watering point. So you can water stuff and maybe something will happen when you do that. That's basically where we're at the moment. So did anyone have a think about whether, there's a question before the break of just, would you rather have the dirt know that it's being hit by water, or have the watering can do something upon the dirt? Anyone have a think about it? Chuck a thought in if you did. I'm erring on the side of the dirt knows about the watering can, just because that's what we've kind of done so far with it. So it knows if this tool happens, do this. If this tool happens, do this. So it kind of makes sense for the dirt to know about its own behavior and the things it changes in it. But it could be a combination of the two. It could be that the watering can's water hits it and it tells the dirt that something happened, which I think is actually much preferred to me than this system, which isn't quite right. And that could be, you know, if we made an extension later of the seed, so rather than the seed, so the moment kind of you click the dirt and something happens, and same with the seed, you click it and something happens. sorry, you click the holes and it fills in. It could be cool, if you just clicked and a seed fell into the ground, and wherever it fell, it happened to plant. That could be a bit cooler, and that would mean that it isn't doing this check like in here. It'll be doing something a little bit different. And then you make it like a different tool extension as well, which could be cool to do. Maybe maybe we'll wrap this one up in the next 20 minutes. We'll really quickly make this plant grow, which seems a little bit, in a way, almost sad that the last 20 minutes of the stream, of this 2-part stream, is oh, and finally there are plants, about time. We start making the plants grow, but then we could do maybe a part 3 that does a little bit of these nicer touches to it, and then also adds things like the plant blooming and some fruit falling off it, and a little bit of physics and stuff like this, just to make it feel a bit nicer, because this feels just terrible right now. This is just oh great, I just click it and it moves around, and the dirt's in front of the thing. It's oh my goodness, this is not great. And there's a few bugs you might have noticed as well. So if when I click the watering can, if I'm changing selection, it actually waters, and that looks super weird. So we could put a bit of code that fixes that. There's some bugs we could fix in a part 3 or something. Any other bugs we noticed? Maybe the dirt tiles. I'm just going to move them all back a bit. Another rendering layer. I'm not sure. Oh, that's why I put them on rendering layer 1. Okay, I'll leave them on rendering layer 1, but maybe I'll move all of the tools onto a rendering layer 1 as well, so they're at least in front, and if they're selected, then they should be on rendering layer 2. So now this should go right in front. Yeah, there we go, that's better. Cool. Might also make them all just a little bit bigger, just a tiny bit nicer. Okay, cool. So let's make it so the watering can sends a message down, and if it happens to, it's going to send a raycast down when we're clicking, and if the raycast hits some dirt, it'll tell the dirt to do something, and the dirt will do something with that information. So we'll do part 1, so the watering can telling the dirt about something. And just real quickly, I'm going to move that there because I'm a little bit pedantic. There we go. So how do we do this? Let's go to our watering can script again. So here's all this stuff that happens. Now we've got the mouse down, the mouse up. We want to make one that will kind of sit, actually I'll put it underneath, that'll be just the mouse button. So we did that before, I think I mentioned it before, where it's neither up nor down. It's just if the mouse button is held every single frame, it sends information. So if the mouse button is being pressed, we're going to send a raycast down into the ground. We're going to go down and we're going to search. Something else we could do to make that look a little bit better maybe with this watering stream here is I'm going to duplicate the watering stream and move it down. So we do actually now have kind of 2 watering streams connected, which looks a little bit garbage. That looks more garbage. Don't ever put me in charge. Okay. That'll do. It's fine. That's good. There we go. Perfect. Okay. So now it will look like it's falling a decent amount. That's going to move that back down again. Oh, wait, but there's a problem with that. There you go. Now there's not. Solved. So the problem I had was that I'm only rotating the watering stream here, but I made that a child, so now when this one rotates, the other one will rotate. Success. Okay, but this is not really the most important thing right now. Let's stop doing this. Great. Okay, so we're going to send this raycast down when the mouse button is pressed. So we can just grab basically our raycast code that we already did from the utility, which is checking for a click. Now this raycast does some stuff with the screen world position and other things like this, but I'm going to use it probably the more usual way, which is simply to so we do a raycast hit, and instead of sending a vector this 0, it's vector 2 0, which kind of is that little hack to do a point raycast. So it just checks for this 1 point on the screen. We're actually going to send it down. So vector 2 dot, I think it is just dot down. And we can use the mouse wheel point again, but in this case the mouse wheel point is just the transform position because we're already assigning it to the same position. So the code is already in the tool, it's already saying make the this thing the same position as the mouse. So we can just say, well, check this thing's, send the raycast from this thing's position downwards. Okay, and then in the watering can, we want to see what does it hit. So let's just do a debug hit on that. Let's just, debug log the hit, and we'll see what we get back out of it, if anything. And I'll move this back up here so it's a bit more visible to everybody. Oh no, I made something really horrible go wrong with that. Oh well. And we can go here. We can see there's a bunch of raycast hits, but I'm not actually getting useful information from it. So again, I'm going to jump into the API because my autocomplete isn't working. So let's just check what is in our raycast hit. Raycast 2D hit, I think. Raycast hit 2D. Oh no. Hit 2D. And we've got a bunch of things. So we've got the collider, the distance, the transform. Here we go. So we get the transform, what was hit, and then we'll get the name of it. So hit dot transform dot name. Let's just get the name. Now, if this is going to be a really intensive game with lots of colliders and stuff going on, you'd actually look at physics layers and you'd work out you know, making sure that only the water, this raycast we're doing that represents the water, will only ever be able to hit the dirt and it can't hit anything else. Because here, for example, we can hit the seed, and that's kind of, if we had lots of things that were like seed, that would become expensive. But for now, we can see it's actually working totally right, normal dirt. And instead of doing this kind of layering thing, which is like the efficient way of doing it, we'll just do it the kind of more like the tag system way, which is much more common. It's much more kind of gamey. So what this means is all of our dirt is going to have a specific tag. So I'm going to say add a tag. I'm going to add into that list. I'm just going to call the tag dirt just to make it nice and simple. And I'm going to select actually the prefab of the dirt. What have I done here? Looks like select the prefab. So it's taking me to the prefab here. You can see this is the prefab information, and in the prefab I'm going to change it to use this dirt tag that we just made, and that should in theory make all of these also change to use the dirt tag. So now instead of debugging the name, I'm going to debug the tag. So transform hit.transform.tag. So let's run that and see what debug log we get. I really need to fix that watering can, it's going to bug me again. Whoops, jump into the console. There we go. We can see they all say dirt, and then over here it's like a bunch of null references, like there isn't a tag assigned to that, or something. Null reference in the tool update. Something very strange happened when I went off the screen, but let's pretend I didn't do that. So it's correctly finding the tag, so that's really good. So now what we can say is if the tag hit.transform.tag equals dirt. This is one of the few times when comparing against a string makes sense in this way. So before I was talking about enums and stuff like this, and like I would prefer if this was an enum that somehow Unity generated in the background, but Unity just gives you a string. So as a programmer, you just check against this string. So if the transform tag is dirt, then we've hit dirt. So what we actually want to do is get this dirt script that's on the dirt. So we want to get this. Now we've previously got the component on objects we already kind of have. So get the component on yourself. But now what we're going to do is we're going to get the dirt component. I'm going to call it dirt script. And we're going to say the hit.transform. So the thing we're hitting, its transform. Or sorry, the hit information of the raycast hit. Get the transform that we're hitting. And then we're going to get component dirt. So we're going to get that script through this chain of the hit, the transform the hit knows about, and the component that the transform knows about. And then on that dirt script, we can run a public function, just like we do on in our tool. We have I think it's a get current tool. So it's going to be a little bit like this, but instead of just getting information and sending it back in, it's actually going to do something. And it doesn't have to be static either, because we're doing it to this specific bit of dirt. We're not doing it generally to all dirt. We're doing it specifically to this one piece of dirt. And like I said, I kind of last time, part one, generally, like almost always things are not static. So if you're ever like, should this be static? The answer is probably no, unless, yeah, very particular circumstances mean that it should be. So in our dirt, I'm going to make a new function, and it's just going to be like maybe watered. So we just know it gets watered if something happens. And I'm going to put a debug log in here that says watered, so I know that that's working. And I'm going to take that name in the watering can. I'm going to say, great, if we have a dirt, so I shouldn't have to do this because I should know that everything, because I've set up the scene, I should know that everything that has a dirt tag definitely has a dirt script. But there are cases where that might not happen. So just to be really careful and make sure I'm not getting any null reference errors while the game is running, I'm going to say if dirt script. So that's shorthand for if dirt script does not equal null. So if dirt script exists, then we're going to say dirt script dot watered. So that will now say, so that's saying if the water does all this stuff, if the water hits that piece of dirt, get the script on that dirt and play this function watered. And then we can basically hand over control of this event over to the dirt, and the dirt can handle the rest of it, which is really what we want. It makes the most logical sense for like us as humans, and also just to keep the code kind of neat, I guess. But again, it's neat in a way that humans understand. There are other ways of writing this that might make maybe less sense to us, but would be much more efficient. And the error I just had is saying that it's inaccessible due to protection level, so I have to make sure that this function is public, so otherwise nothing else can access it. So we'll just see if that works. So we select the watering can, there we go, dirt and watered. So dirt, it's doing this transform thing, so I'll get rid of that debug log. And it was also doing watered, so it's definitely watering it, which is awesome. So the first thing we want to do probably for a player is to actually give them some visual feedback on what's happening. So let them know that, hey, the fact that you hit that water, that hit the dirt with the water, that means something. So we have the sprite renderer already. So what we can do is get the sprite renderer, get the color, and just tint it a little bit. So I'm going to make a new serialized field. And I'm going to call it maybe... I call it, it's a type of color, and I might call it watered dirt color or something, or watered color maybe. And I'm going to say that we set the sprite renderer color to the watered color if we've been watered. So we could just change this immediately, but again, it's a prefab, so the easiest way to do it is to select the prefab in the project, and then we can change this watered color here to something good. So you'll notice even though I'm changing the colors here, it doesn't seem to be changing anything at all. I'll show you on actually a piece of dirt first. Actually, it's already kind of changing all of them, right? Because it's a prefab. It doesn't seem to be actually changing what's going on, and that's because the alpha is set to 0. So if I increase the alpha... Oh, sorry, I'm totally doing the wrong thing. I should be doing it on the sprite renderer. Whoops, to get an idea of what color we want to do. So I want to just make sure the color I'm choosing here kind of looks not too bad. So I shouldn't have... I'm going to reset this to... set to the value of... I think it's this one. I want to just reset its value, so revert to prefab, like that. And I'm just going to check what a good kind of damp color might be. So maybe a little bit like blue. Let's just go with that. So I'm going to copy those values, and I'll undo that change because I don't actually want it there. And I'm going to set it into my my variable here. So that's what that looks like, that color. So in theory, now, fingers crossed. Hello, little shrimp 3. Welcome to the channel. In theory now, if we select our watering can and we... Oh, no, it turned to red. But otherwise it seems okay. Something weird is happening where it's not like... Oh, you turned blue. That's so funny. Of course, I changed it on the dirt instead of on the prefab, didn't I? Silly. So let's select that and put it on the dirt, on the prefab. And then we can just make sure these are all revert to the prefab setting. They all look okay. Good. There we go. Okay, let's try it again. Yeah, all right. Cool. Now maybe we want to, I don't know if we do, but maybe we want to actually make it so that the water kind of goes away after a little while. So maybe we could put like water as a timer. So like rather than it being kind of now the ground is watered and it's watered forever, maybe it's only watered for a little bit of time. But in any case, before we do that, let's actually just make it grow. So let's say if it's got a seed and it's been watered, then it should grow, right? And this is where this we really start thinking about the state of the dirt. So it's not just all like these kind of all these if statements and stuff we've got here are a little bit yeah, they get like a little bit confusing. There's just a lot of kind of if this and if that kind of going on, which is in some ways is okay, but we really want to we want to know what state the it's currently in. So maybe before I was talking about enums, maybe I will actually just make an enum that is the state of the plant, so we kind of know what's going on. So let's go enum. Let's call it plant state. There's a type, but because enums are a type of thing, so I'm going to I actually write my enums in all capitals. That's what I tend to do, but for now I'll do it kind of more like a variable name or something, or a type. Sorry, a normal type in C#. So plant state, and we've got what are the states we've got? We've got it's just normal dirt, cert dirt. It could be a hole, so you've dug into it. It could be a mound, so it's been seeded, it has a seed in it. It could be a seedling. And then let's have a look at our art. What else have we got? So we've got plant 1, 2, 3. We've got 3 of those plants. Maybe we'll make those an animation, and then we can just have mound. Maybe we can just have plant there, and I can call this maybe dirt state instead of plant state. Dirt state. Okay, so dirt, hole, mound, plant. Great. And now I need to make a new thing that is dirt state, and it's going to be like I did before, dirt state with a lowercase d, and I'm actually going to set the first one to being the dirt. Now I can't just write dirt, that's not quite how it works. I actually have to write dirt state dot dirt. So I can write cert dirt, there we go. That's just how you kind of type out enums. Okay, so that's our first state. Now instead of using this kind of weird stuff I'm doing here, I'm gonna start using this state stuff instead. So the current tool, so this is some of the state changes we already have. So if the tool's name is shovel, change the sprites to be a hole. So instead of checking if the tool's name, actually I do need to check if the tool name is shovel, but when we change the sprite to a hole, I'm just going to make sure I've got my curly brackets all the way around. I'm actually going to say, well, the dirt state is now dirt state dot hole. And here where I'm checking, I'm saying, is the S renderer a hole? I'm going to get rid of that, and I'm going to instead basically do this kind of bit of code, but with the double equals because it's a comparison rather than an assignation. So if the tool is a seed and the dirt state is a hole, then we're going to set it to be a mound, and I'm also going to, again, change the dirt state to be a mound. So dirt state dot mound. So you can kind of see where we're going with this. And now here we've got this watered thing. So the watered isn't really, you can be both states at once. You could be a hole and watered, or you could be a mound and watered, or you could be just normal dirt and watered. So watered will be just a Boolean variable. So we can just say bool watered equals, and it starts off false. Thank you, Little Shrimp. Little Shrimp says, I like this game so far. And that makes me very happy. When we water it, we're going to say watered equals true. So now we're internally tracking, is it watered or not? We know. And then the color, of course, has changed to tell the players that it's changed state. So this hasn't changed anything visually. This should all work the same, and we can just double check it. It's just a good bit of practice to have if you're not sure. If you've done a few code changes, just jump in and just double check that everything still works as you expect. And it looks like it does, which is really cool. And we can see we can even dig holes and it will stay wet, which is awesome. So that's pretty good so far. So the next thing is to actually have the plant grow. Let's do it. All right. So I'm going to make a child for each of the dirts. So I might just select this one. So that's a prefab. So I'm going to treat this one now like the master, and I'm going to assign this back into the prefab when we've done a little bit of work on it. So I'm going to give it a child. This is going to be the plant. Plant. I'll put an exclamation mark on it. I'm We can go into our art and we're going to choose, I'm actually going to grab all 3 of these and I'm going to drag them on to the plant. And now it's come up with this weird box. It's like, whoa, new animation. So what happened from, I'll do that again for anyone who might have missed it. I selected 3 of these sprites, so all 3 of those, and I dragged them into the scene. And Unity's like, great, you've selected multiple sprites, you must have an animation. So this is, I'm going to make a new folder. Actually, I'll keep it in the art folder, but I'll make a new folder inside that. I'm going to call that animations. And in this, I'm just going to go into animations folder and I'm going to call it the plant animation. There we go. And now it exists as a child. And hopefully if we play, we should be able to see that animation happen. Oh, it's a little bit fast over there. But there it is, it's a plant. That's pretty cool. So we want to edit the animation. So we're going to jump into the animation editor very quickly just to slow that down because it's a little bit too much. So we go into window animation and we can see, because we have the plant, so if you have the plant selected, it comes up with plant animation up here. So it already has it selected. And depending on the mode you're in, it usually, oh, actually I'll open this up and if you, yeah, with that open, you can actually see, it gives you, it's a bit hard to see on, even on my screen. So for you, if you're like viewing this on YouTube, whatever, it's going to, sorry, on Twitch, it's going to be, well, Twitch or YouTube because it does go on YouTube. You can see the, like these tiny little, it'll be hard to see these tiny little sprites in here. But what we can see if we zoom out, this is the time. So it's like within 2 seconds it plays all of them. So if we want that to take maybe instead like, I don't know, 10 seconds, we can grab them all and just stretch it out. So let's make that take, oh, sample size is 12, sorry. So maybe more like, yeah, like here. And we can test that. We can hit play. There it is. And you'll see it flicks on that last one, and that's because this is a looping animation. So as soon as it hits this frame, it jumps back to the end. Now, if you want to have if you want this to loop forever, you could actually, like if we can copy this keyframe, or even could even just drag this sprite back in again. So that's how you can add things to these kind of animations. You can add new frames by dragging them in. So if I put this on now, it'll feel like it has that time for all of them. But actually, I want to just make it so that it stops on the last frame. It doesn't ever loop because a plant never ungrows, right? Like it's never going to uncurl back down. It's always going to just end in this one state. So it's a difference in the animation style. It's not a looping animation. It's a clamp forever, which means that it just gets to the end and then it never changes. So we can change that, I think, on the animation itself. So we'll go on to the animation. It's got like loop pose and loop time. So I'm going to turn that off. And that means now hopefully it will just play once. Cool, and it just sits there. Awesome. And that's now a child of this one particular dirt we've got. So if I apply this, so this selects the prefab, but if I have this particular version of this dirt down here selected, and I actually hit apply, that will make it so that the default prefab is like all of the prefab. So this prefab applies to all of, becomes the default prefab, and therefore everything is like it. So I'll hit apply. And now all of our dirt should all have plants, which will all curl up creepily simultaneously, and that's fine. But that looks really good, and then we can dig and ruin them and plant a seed, and all of our other logic is still working as we expect. Okay. So we can probably, given that we know the plants there, we can probably move it up a little bit because that does grow out of a mound. And now we just need to make it so our logic actually only grows that plant if it's watered and we're in the right state. So we could even put that in update. We could go, okay, if we have a mound, so if the current state is mound, so put it here. If dirt state equals mound, and we'll do an and. So if it's also true that it's watered, whoops. Oh no, what have I done? If it's also true that it's watered, then we're going to grow the plant. Grow plant. So the easiest way to do this is the same way that we turned on and off the water stream, which is just to set it active. So set active true, set active false. Where's that down? Where's that now? There we go, set active in here. So that's the easiest way to do it, and it means that our dirt just needs another serialized field. I'm going to put it at the top because I think it's the most important. And it's going to be a game object, and it's going to be the plants. Awesome. So if there's a mound and it's watered, then I'm going to say plant dot set active true. Woohoo! Now, as an extra bonus, because I'm a bit cheeky, I'm actually going to make it so that if you use the shovel, it's going to kill the plant. Set plant false. Oh no. So we can also kill the plant. It's a bit naughty, but we'll do that. Little Shrimp says, if only pumpkins grew that fast. So I think that was back when the animation was looping super, super quickly. And you know what? I have a pumpkin growing in my garden that actually I found in our compost. We have a worm farm, little worm farm that we're growing. And there was like a pumpkin we put in there one day, and then some seeds grew from the pumpkin. So I like went to put in like a compost in with the worms, and this pumpkin seedling was there, and I was like, okay, so I took it and I planted it in the garden, and it's really small. Like right now, it's like I don't know, like 10, 20 centimeters or something. But I'm just waiting. As soon as I move it to a bigger pot, it's going to absolutely go out of control, and it's going to just like fly out of its planter, and I'm actually really excited for it. Pumpkin plants are like when they decide that it's time to go, like it's time to become pumpkins, it's like it's going to happen. Okay, so let's see how we've gone with this active thing. Oh, so they all still play. So what did I forget to do? I forgot to actually... So actually there's two things I forgot. One is that I moved this plant up a little bit for the mound, but I didn't apply it to all of them. And the other is that they actually all have to start disabled, otherwise we get them all turning up immediately. So let's try that again. I've made those changes now. Cool, so none of them are growing. Awesome. I can't plant anything, so I'll... Oh no, I have a bug. Let's see. I've got this error. Has not been assigned. So I never told it what the plant is. I'm so silly, I do this all the time. So I have to drag this plant into the slot here, just so it knows about it. And same deal, apply. So it now applies to all of the prefabs. And we'll hit play. Cool, no more errors. I can dig a hole. I can water. I can plant seed. Whoa, it grew a plant. That's awesome. Finally, our little gardening game is actually growing a garden. Yay! Hope we're all feeling pretty good about that. So there's like a few more things I want to add to it that are, I guess, not super exciting. And I could do it as a part 3, maybe next week or the week after, or I killed that one. Killed them all. Or I can actually do them right now in like maybe the next half hour. But I think maybe I'll do like a stream part 3 because it's getting pretty late over here. So if anyone has any final questions, now is the time to put them in the chat. If you have any ideas about what you might want to see in a part 3 of the stream, then pop them in there as well. What I think would be kind of nice is to like maybe add some more particle effects or something to the water, and to make it so that the watering can, the dirt actually dries out over time, and the plant will only grow if it's actually got water on it, and maybe the plants grow a little bit slower, so they'll only grow in the right kind of conditions. And then also make it, because we've got these cute little flowers in here. Let me just go back to the scene view. Cute little flowers. Have like these cute little flowers pop in a little bit randomly, so they pop in different parts of the plant, and they grow into fruit, because we all love fruit. And then add little bits of physics and stuff to it, just to make the game kind of feel really nice. So I think maybe we'll do that all in part 3, but if you have more ideas, pop them in there in the chat, pop them in the YouTube comments, or you can just like Twitter me directly, tweet me directly, or whatnot. Yeah. I think that's pretty good. All right, cool. Well, thank you all for watching this stream. If you have any questions, message me or chuck a question in the channel. And I will upload, so I'll, like I did with the last set of code, I'll comment it all again, I'll update the comments, and I'll put it in a new zip that is actually for this stream specifically. So if you kind of want to go back in time and see like what the code was like at the beginning of this stream, there'll be a zip for that, and then there'll be a zip for the code at the end of the stream. Because we made some pretty big changes to like the watering can tool and stuff like this. And yeah, you can jump in your own time and just go through that code and like see what it looks like. Awesome. Thank you very much for watching today, for tuning in. It's been really fun. And if you have any ideas as well for future streams, that would be really cool. I'm thinking the next, maybe not next one, depending on if we do part 3 for this or not. The next one might be like a one where I actually I'll be working with an artist as well. So we'll have both me and an artist co-creating like a dress-up game or something at the same time. So you'll get to hear us like chatting to each other and probably like a bit of shit talking and just seeing how it is that we would actually collaborate in real time. Like how does it actually work when you have like a programmer and an artist making things, and how do they bring their assets together, and how do you like communicate the requirements of the game design and stuff like this between you. So we might do that and make like a little dress-up game or something. And that will probably be like 2 weeks or maybe a month from now, but I'll update the channel, so feel free to drop in and have a look at that. And I look forward to seeing you all next time. And yeah, awesome. Take care.